All right, let's talk about something that shows up all the time in coding interviews, especially at the top tech companies. It's a technique that can make you look like an absolute genius because it turns a really clunky, slow solution into something super elegant and fast. We're going to crack the sliding window pattern.
And you know what? That's not just hype. This is exactly the kind of question that can make or break an interview. It seems complicated, it trips up a ton of really smart people, but the secret, the actual solution, is shockingly short and simple once you see it. So what is this big, scary challenge that places like Meta, Apple, Amazon, Netflix, and Google love to ask? Let's just get right into it and lay out the problem. Okay, so here's the task. You're given a string, and you have to find the longest part of that string, the longest substring that has 0 repeating characters. So if you get the string ABC, ABCB, the longest piece without any repeats is ABC. The length of that is 3. So the answer is 3. Seems straightforward enough, right? But how do you actually find that in a way that's fast and efficient? Now, your first instinct might be, okay, I'll just check every single possible substring. And yeah, you could totally do that, but that's kind of the trap. In a high-pressure interview, that's the slow road, and it's not the one they want you to take. Let's see why. So here's the night and day difference. The brute force way, checking everything, has a time complexity we call O(n) squared, or n squared. All that means is that if the string gets twice as long, the time it takes to solve it could get 4 times longer. It gets out of control really, really fast. But the sliding window approach, it's O(n), or linear time. That's the gold standard. It means if the string doubles, the time just doubles. It's incredibly efficient because it solves the whole thing in just one single pass. So how do we get to that lightning-fast O(n) solution? The whole trick is to avoid redoing work. We need a clever way to check substrings without starting from scratch every single time. And that is the big aha moment behind the sliding window. So what is a sliding window? I want you to picture this. You have 2 fingers on a string. Your left finger is the left pointer, and your right finger is the right pointer. The space between your fingers is the window. You make the window bigger by moving your right finger to the right, and you shrink it by moving your left finger to the right. The secret sauce is having a little notepad, in our case, a hash set, that instantly remembers every character inside our current window. All right, enough theory. Talk is cheap, right? The absolute best way to get this is to see it in action. So let's pull up that elegant 10-line solution and walk through it, step by step. And here it is. Looks pretty small, doesn't it? But every piece here is doing some heavy lifting. We start by creating a set called scene to be our memory of characters in the window. We set our left pointer to the start and an ants variable to keep track of our best score. Then the main engine is a loop that moves our right pointer across the string, one character at a time. Okay, let's trace this with our example string, ABC, ABCB. We start at square 1. Both our left and right pointers are at the very beginning, at index 0, pointing at the letter A. We add A to our scene set, and our longest substring so far is 1. Easy enough. Now the fun begins. We start expanding. The right pointer moves 1 step to B. Is B in our scene set? Nope. Great. We add it. The window is now A, B, length is 2. We update our answer. Let's do it again. Right moves to C. Is C in scene? Nope. Perfect. Add it. The window is ABC, length is 3. Our answer is now 3. And here it is. This is where the magic happens. The right pointer moves 1 more step to index 3. The character there is A. We check our scene set, and uh-oh, we've seen A before. It's already in our set. Our current window, ABCA, is invalid because it has a repeating character. So what do? We can't keep expanding. This is where that while loop kicks in. To fix the window, we have to shrink it from the left until the duplicate is gone. So we look at our left pointer, which is still on the first A. We remove that character from our scene set, and then we slide the left pointer 1 spot to the right. Now our window is BCA. It's valid again, and we're ready to continue. And that's the whole dance, really. It's just a simple rhythm. The right pointer pushes forward, expanding our window. And as soon as we hit a character we've already seen, the left pointer scoots forward just enough to kick out the old duplicate and make things right again. All the while, we're constantly checking, is this new window the biggest one we've seen yet? So after that whole process of expand, shrink, has gone all the way to the end of the string, our ants variable is left holding the maximum length it ever found. And for ABCABCB, that maximum was, and still is, 3. Getting this down is a huge confidence booster. But, in those really tough interviews, they're not just checking if you know a pattern. They want to see if you can adapt it when things get harder. So, you feel pretty good about the sliding window now? Because the real test of understanding often comes with the follow-up question. And that follow-up is often a problem called minimum window substring. It uses the same core sliding window idea, but it adds a few more twists. You're trying to find the smallest window that contains a certain set of characters. And honestly, this problem is famous for being the one where a lot of developers get stuck. So at the end of the day, the sliding window is an absolutely essential tool for your toolbox. But it's just one tool. It's one of many powerful patterns that can unlock these interview problems. And it kind of makes you wonder, doesn't it? What other crucial patterns might you be missing?